Hi, I'm DJ Ware. On this episode of the Cyber Gizmo, I'm going to be looking back into the file systems again. It's been about 11 months since the last time I looked at this. I noticed a lot of people are still watching that old video. So I thought I would give this an update. There has been quite a bit of updates going on, especially with btrFS. And so I thought, well, it might be a good time to drag this back out and see. The only thing that I can't test is ZFS. It's currently in use at the moment. I'm bringing up another file system onto it, so it's busy copying files. This is not a good time to be doing benchmarks on it while it's busy anyway. So I'm going to look at ext4, btrFS, XFS, Stratis, and F2FS. Had a number of people ask about F2FS in the last one, so I'll put it in the mix and we'll take a look at it and see what's going on with it. Tests that I'm going to be doing today are conducted on a virtual machine, so I won't be using actual hardware to do this. Again, the hardware is tied up, so yeah, I don't want to disturb it, so I'll put this on a virtual machine and do it. So this is not a good, don't be comparing these numbers to what was published last time because that was done on hardware. So, but it should give you at least an idea between the two, between all of them, how well their relative performance are one against the other, because they are going to run on the same machines. I ran a couple of things. So the first thing I did was I ran the Phoronix benchmarks and ran a standard read-write on sequential and then a read-write on random, and that was using FIO. I noticed there's a lot of comments on the Reddit thread for btrFS about FIO, but those two are very common. They are also very common workloads that you'll find on Linux as well. I mean, sequential reads and writes are everyday stuff. Random reads and writes, yeah, there's a few things that do that. Quite a few things, actually, that still use random reads and writes. I wanted to check those out and see if some of the things I saw the last time were still happening, particularly with some of the btrFS IOs. The other thing I want to look at is running my iozone benchmark, and this one actually brings in workloads that are very common to Linux. If you've seen my previous videos, I've talked about the methodology before. I'll go through it again on this video in case you're not familiar with it as to what kinds of workloads we're going to be looking at. Benchmarks can't really get close to real-world applications, but you can design benchmarks that will use IOs similar to the ones you will encounter in a Linux environment, particularly if you're executing programs and loading stuff into memory off of your file system. Yeah, you're going to find these kinds of workloads are very common. The first one I'm going to be looking at today, these are all iozone. And the initial write is the very first thing that it always does, which is to write out a file and measure the amount of time and the performance that you get from it. It's normal for an initial write performance to be lower than the performance of rewriting a file due to this overhead information. The first one is looking at the initial write for btrFS. From top to bottom, it goes from a single workload, then two simultaneous, then 3, then 4, then 5. And that's the maximum. And that's what that's trying to do, is to insert enough IO depth into the system that the system will then start to hopefully exhibit some loading that may back up IO requests or IO wait. You may see other kinds of things, the buffering back into memory, waiting for IOs to clear. So, and you'll notice that btrFS has a ramp up, just like it always has. It gets up to about 3 simultaneous users. Now, when I'm talking about 3 simultaneous users, I'm talking about 3 simultaneous writes to the file system. So, and then you'll notice it slides back as it gets up to 5. I noticed that there was some write-ups on the 617 or the Linux kernel 6.1, and they talk about that there wasn't any appreciable gain in performance once they got up to an I/O depth of 4. And that seems to be suggesting that kind of thing there as well. I did notice that on some of the writes, not this one in particular, but some of the writes there with btrFS, there was some high I/O wait times going on. We'll talk about those when we get to them. But yeah, it wasn't particularly with the initial write, because that's sequential. That's just running it out onto the disk. ext4, same kind of behavior. It ramps up, and then you'll see it kind of slide back on on 3 simultaneous IOs, and then goes up again. There's definitely some loading that's going on there. F2FS seems to perform pretty linearly until you get to 5, and then it drops off in its performance. Stratis, this is a new benchmark. I have never really included it in this benchmark before, but I feel like it's starting to get close enough that maybe we should start paying some attention to it. It does fairly good up to about 3, drops back for a little bit on 4, and then gains a little bit on 5. XFS has a nice, smooth ramp up. A read is just like it says, it's just going to read sequentially an existing file. In this mode, we see btrFS has taken some time to ramp up from 1 to 2 users, and also from 2 to 3. There's a big gap in ramp up between when it starts and when it finally gets up to 4. Then there's a slight gain at 5. Again, that could be heralding back to the comments by the developers talking about that the I/O depth of 4 seems to peak out the btrFS system. So, and so it could be why that is sliding back on 5 a little bit. ext4, of course, it's really meant for more around 3 simultaneous IOs, and then it kind of drops back. F2FS, of course, that's a file system that was developed by Samsung in order to take advantages of NRAND devices. So that would be, your SD cards and that like. So it gains pretty well. It's pretty smooth up until about 5, and then it drops off. Stratis seems to do pretty good up to about 3. There's a slight back off at 4, and then it seems to pick back up again at 5 simultaneous users. XFS has an exhibited up to 3, and then it kind of drops back and then kind of hangs back and stays right around that mark there around 3,000. Reread. This test measures the performance of reading a file that has recently been read. That's normal for the performance to be higher, as the operating system generally maintains a cache of the data for files that were recently read. Now, btrFS, again, we see this slow ramp up till it goes up pretty smoothly up to about 3, and then there's kind of a slight gain to 4 and even a smaller gain to 5. Again, that seems to be pointing to the I/O depth of 4 that some of the devs were talking about, possibly. ext4, we see it gradually gets up to around 3, and then there's a slight gain at 4, and then it drops back at 5 a little bit. We've seen that behavior before on other benchmarks that I have shown you. F2FS gains up till about 4, and then it drops back at the 5th. Also, Stratis gains pretty smoothly up to 4 and then drops back at 5 as well. XFS, we see that same behavior where it gains very substantially up to around 3, and then 4 and 5, it's pulling back. The FRead measures the performance of reading a file using the library functions FRead. So this would be C programs generally, and this would be performing buffered and blocked read operations. This is indicative of a C program, basically, that's running. So it's kind of workloads that you would see done by the utilities on the system, your compilers, your copy routines, all that kind of stuff. And we see btrFS kind of smooths up to about 3, and then there's this huge fallback at 4 and 5. This is one of the areas where I saw high numbers of I/O wait, and this was on the read. So something was queuing the reads up and preventing it. It was almost like it was blocking the system. I saw the same behavior in ext4. That could be a problem with the drive. That is a new drive, and it is possible that this may be pointing to an issue with that particular hardware and not pointing to btrFS or ext4. So I'll have to keep an eye on that. That could be retries. I didn't see anything in the logs, but if it's all internal, you may not see it until the internal firmware gives up. So, yeah, I mean, that's possible. Also, F2FS, we see a pretty smooth gain up to on 1 and 2, drops back at 3, drops back more at 4 and 5. So there could be something going on here with this particular drive. Like I said, it is brand new, and who knows what's going on with it, but there's definitely something retrying. Stratis gets out to about 3, drops back at 4 and 5, and then XFS does pretty well up to about 3, and then it starts to slowly back off at 4 and 5. FWrite, this is also a C library call, so this is writing a file using the library functions FWrite to do that. In this case, btrFS kind of starts out good and then drops back slowly. Again, saw high I/O weights here for that. ext4 gets out pretty good, out to about 2, and then it starts to fall back. The I/O weights were high, but they weren't up in the 45% that the btrFS was. They were up around 12 to 18% on ext4. F2FS kind of smooth out to about 3, doesn't go up or down too much, and then it falls off at 4 and 5. Stratis, about the same thing, 3 and 4 and 2, 3, 1, 2, and 3 do okay, but then it drops off somewhat at. It drops off somewhat at 4 and 5. XFS peaks out reaches its maximum at around 2 concurrent users. Kind of hangs out at 3 and 4, and then drops back a little bit at 5. Mixed workload measures the performance of reading and writing a file, with access being made to random locations within that file. We don't see the issue with the drive here on this one. The mixed workload seems to be working okay. There is a slow ramp up with btrFS, and again, it does okay out at about 3 and 4 and 5. It seems to do really well out there. ext4, we're seeing the same kind of performance where as soon as I get out past the single user, the performance is pretty steady for 2, 3, 4, and 5 concurrent users. F2FS, same thing. Takes a little bit longer to get out past 2, but then 3, 4, and 5 seem to be out pretty close to where the other two, where the rest of the system is performing. Not quite as well as the rest of the file systems, but pretty close. So Stratis, same thing. You see a little bit of a gain, and then it does well at 3, 4, and 5. XFS, same thing. Takes a little while to get going. Doesn't have quite enough. I mean, the drives that we're using here are really fast, and it's probably, taking a while to load up enough I/O to bring the thing into, into a busy mode to actually get it moving. PReads, those are reading from a file without a file pointer change. It'll usually skip into the file by a particular count of bytes and then start reading. So that would indicate a file that has some kind of header, and that we've read enough of the header that we then can skip the rest of it, and we're going straight into where the data would start in the file. That might be a graphics image, that could be a spreadsheet, could be a zip file, anything like that has header information in it. So in this case, btrFS does pretty well. I mean, they're all pretty equal here. until you get down to Stratis. Stratis is back a little bit, and then XFS is out a little bit at 1, 2, and 3, but then it starts to drop back at 4 and 5. Whereas btrFS seems to be absorbing that load pretty smoothly out until it gets to 4, and then there's only a slight increase on 5. Again, talking back to the number of IOs that were the IO depth that when it gets above 4 could be the problem there. So PRead skips into the file a bit, and this time we're going to write the information to the file. So we've read the header, we know where the file begins, and now we're going to skip to it and write the data. That could be updating an image, could be updating a spreadsheet, could be updating a zip file. So, yep, those are very common to see have happen on Linux systems. Not much difference here for the first 3. They're all pretty even within, you know, a few tens of megabytes of I/O within each other, and then you get a pretty hefty slide off with Stratis, and Stratis did have some pretty severe I/O wait times, as you can imagine, where it seemed to be doing fine. And then right as soon as it got to 3, the I/O times went absolutely nuts. So it sort of pegged, the system sort of halted, and so there could be it could be a drive problem again, but I don't think so, because I think we would have seen that with the other file systems. I think this is a problem in Stratis. So anyway, XFS looks pretty even, looks pretty good, as you would expect from it. The random read test measures the performance reading a file with access being made to random locations within the file. This would be indicative probably of a database of some kind. The random reads on btrFS, not bad. They're not bad at all. The ext4 does well out to about 3 concurrent users, then it falls back. FWrite does pretty okay out to about 4, and then it starts to drop back at 5, but it never really reaches the level of performance that the device is capable of. So it's got some overhead here that's kind of getting in the way. Also, Stratis does pretty good out to about 3, and then it starts to fade, and then XFS does pretty good out to about 3, and then it starts to fade. So you can kind of see the similarity between Stratis and XFS because they both use XFS. Random writes are just randomly writing to various locations on a file. So you can see that, yeah, it just kind of goes off the scale for btrFS. It does quite well on the writes for this. So does ext4. FWrite, it's okay. Stratis is okay. XFS, this is not one of XFS's strong suits, but the rewrite, this one measures the performance of writing a file that already exists. So when a file is written that already exists, it takes less activity to get it updated, because all it's got to do is the metadata is already there. All it's doing is finding an offset, positioning the head. So the rewrite performance for this can be much higher than creating a new file, of course. And as you can see, yeah, this is where you find out just how fast your device is, because this is what's really going to push it. btrFS drops off at 5. ext4 drops off at about, looks like 2 or 3. And then FWrite drops off at about 2 or 3 as well. Stratis is doing quite well all the way out to 5. Saw that behavior before when I looked at this last time. And then XFS, it kind of bounces around a little bit, and that's probably the size of the I/O cache is being filled. I did notice there was some I/O waiting going on here as well. Reverse read. Reverse reads this is pretty common in compilers, where they'll read the file forward and backward. btrFS does well out to about 5, then drops back. ext4 does quite well out to about 3 and drops back. FWrite, it's okay. It's not great, but it's okay. Stratis is surprising here. It's doing quite well. Not quite as well as XFS or as well as btrFS. So the last one I have is a strided read. This would be very common in a database situation where you read a fixed amount, like you're reading an index, and then you skip a certain amount and you start to read again. Only a longer read because this time you're in the data block and you're pulling the data off for the database. Yeah, because of the nature of jumping ahead, reading back, jumping ahead, reading back. This is the kind, you won't see device performance level. It won't reach the device level performance because it's there's a lot of reading, wait. There's some latency in order to load the buffers and for something to interpret it so that it knows where to go next in the file. So yeah, they're all pretty equal. I would say btrFS does better out in 4 and 5. And then you have some falling off at XFS, and Stratis kind of falls off at 3. F2FS, again, it's okay, but it's not great. And then ext4, of course, does all right out to about 3, and then it drops back. So, yeah, I mean, for a single user workstation, any of these are fine. Yeah, F2FS, you may experience some latency with that. So when I was running FIO, I noticed that in those tests, let's take a look at that data. Those are mostly sequential read and writes and random read and writes, but they're using 4K buffer sizes. And so what this is an attempt to do is to find out if I can overrun the buffer and cause problems in the file system or the file system handler so that I can see that there might be something that's going on that could create a logjam in the system, or it could start to busy out any additional IOs and slow things down to a crawl. We've seen that kind of behavior in Linux before, where things are really slowed down. So let's take a look at the IOPS and also the megabytes per second, and then we'll come back and talk about it. And that is where I'm going to leave things. So I hope you enjoyed this video today on some of the I/O. I'll try to get an update for you for ZFS as soon as this is done. It's something I got to do. I want to do. I'm trying to reduce the amount of storage I have here. I've got some drives that are aging out, and so I've got the storage capacity for it on the ZFS array, so I'm going to move it over there. Hope to see you all again real soon. Bye for now.